Welcome back, everyone. Over the next set of videos, what we'll do is we'll continue to walk through our model data analysis pipeline that we'll use to analyze the open data set that we will use for the remainder of this section as we learn how to process some motion capture data here. So if we just bring back our general data analysis pipeline, the last couple of videos really focused on making sure that we understand the data. So we reviewed the paper and some of the details about how the data were stored and organized, both through the text and in MATLAB. And so next what we're going to do is really focus on the remaining steps. So one of the things that we have here, if we look at our data set, if we go back to our manuscript here, one of the things that you'll notice is that we have a set of, in this case, joint angles. So here's the ankle, knee, and hip for different tasks. So normal walking, heel walking, toe walking, and then both ascending and descending a step. So one reason why we might design a study like this is to understand how different aspects of our kinematics or kinetics change as a function of the task we're performing. So what we'll be doing over the next set of steps and through a couple of scripts is asking how changing from normal walking to heel or toe walking impacts our peak ankle dorsiflexion and peak knee flexion. So if we think about what we need to do to accomplish that, well, first we have many different trials of each task for each participant. And what we would like to do is compute some average trajectory for these joint angle or average joint angle trajectories for each participant, and then look at how the peak of those trajectories changes across these different tasks. So that's what we're going to walk through. So it's a very sort of basic algorithm that we need to develop and move into our code so that we can process our data and extract some meaningful values. So let's take a look at the code that we will be working with here. So what we're going to do to make this more interactive and just give everyone some practice with coding is that I will walk through completed scripts here. So there were two main scripts for this analysis. But what you'll find on the GitHub directory are several incomplete versions of each piece of code. And so in the README file for the GitHub, what you'll find is text that describes for each code snippet what you need to complete to move on to the next step. And so as you complete those tasks, you can use your own code and continue to build on it, or just open the new code or the more advanced piece of code and work from there. Okay? So I'll talk through this in video, and then the idea is that you would then go back on your own and try to complete the task. All right, so let's start. So here at the top of the file here, I just have a description of the purpose of this script. And one of the first things that we'll do just to sort of clean up our workspace is clear our console, delete any variables in our workspace, and close all of the open figure windows. Okay? So that's not something you have to do in all your scripts. It's just something that I like to do in this context so that we have a clean slate to begin with. So in general, when writing data analysis scripts, one of the things that I personally like to do is to start off by declaring variables that I might use later on in the script. So one common thing that I do in almost all of my data analysis scripts is that I have some variable called home, and that stores the directory where my scripts are located. Okay? So normally I have a folder where I have my analysis scripts. Within that folder, there's another subdirectory where I store my data. So here, if I go to MATLAB, actually let's go ahead and do this. Okay, so now if I go back to MATLAB, I have a clear workspace, clear console, and I can see here in my folder that I have a file that's compiled jointangledata.m. And so when I type home equals cd, this home directory is just where I am currently located in my current folder within MATLAB. So next, I know that what I need to do is I need to systematically go through and load data for each participant, maybe do some calculations, store those results in some form, and then do that for all 50 participants. So generally, when you know that you're going to repeat a set of commands and essentially grow an array or a matrix, it's good to do what's called pre-allocate space for that matrix or array. So in this case, I'm going to be computing the average joint angle trajectories for each participant for each of the 5 walking tasks. So I know that for my kinematic data, so if we refer back to the manuscript, that I have 12 joint angles in each data set. Okay, so that's it. So there were marker data that were recorded. They were then processed to compute 12 joint angles. Those joint angles are then represented as a function of the gate cycle. So they're what we call time normalized. So there are 101 points corresponding to 0 to 100% of the gate cycle. And then I also know that I have 50 participants. So if I want to store a matrix that is 12 rows, 12 joint angles, by 101 columns for each of the percentages of the gate cycle, then I also need a third dimension. You can think about these, if a matrix is like a sheet of paper, then this third dimension is like another piece of paper. Right? So I have a 50 sheet deep array for each of these variables. Okay. So in this case, I'm just deciding to create a separate array for each of the tasks. Just an easier way to deal with the data later on. Okay. And so just as a reminder, if we go back to our main folder, so you always want to get comfortable as you're writing code, navigating back and forth between your code and folders on your computer where your data, scripts, or other files are stored. So all of my data are stored in this all subjects folder, and if I open it, I now again see all the names of my files. And so one thing that you'll hopefully remember is that one thing we did early on as we were preparing our data for analysis is that we made sure that all of our participant IDs were 2 digits. And then you'll see, well, that's how we use this shortly. All right. So when pre-allocating, I generally will pre-allocate with 0. So this is just a 12 by 101 by 50 array of zeros. So I'll just go ahead and walk through this code. So let's just highlight this all the way through line 26. So this is going to move us into the directory where our data are stored. Let me first make sure I'm in the correct directory. Yes, I'm in the folder where my script is stored. Okay. So I'll highlight this, right click, evaluate selection, and now I should be in the directory where my data are stored. Okay, so that worked. All right, so one of the things that we're going to do in this script is that we're actually going to recreate a version of the figure from the paper that we just looked at. Okay. So in this figure, if you look at the caption and read it closely, it shows the joint angles for 3 joints for all 50 participants for the 5 tasks, where each line, each gray line here represents individual joint angles, so for a single cycle, and then the black line is the average across participants. Okay. So once you've completed all the assignments for this piece of code, you should have a figure that looks exactly like what we have here in the manuscript. Okay, so I know that I want to create a figure, and one of the things I again like to do is create my figures often up top, give them a name. So I save a variable, f1 equals figure. F1 is what's called a handle to the figure, but it just allows you to access or manipulate features of that figure. So as an example, things that I like to do when I open my figures or initialize those figures, I like to turn off the number title, so that just instead of having 1, 2, 3, 4, I just remove those numbers, and then I like to give the figure an informative name. Okay? So that way when the figure is open and I hover over it, so we'll just do this now. If I highlight this text, code, evaluate selection, you see this says manuscript figure 3. And if I hover over my MATLAB window here, I see it says manuscript figure 3 there as well. So when you have lots of figures open, it's much easier to navigate between them when they have meaningful names than when they just say figure 1, 2, 3, 4, and so on. So there are going to be a few different types of constructions that we use throughout this code. First, I know that I need to go through and open, at the very least open, each of the files for my 50 participants. So you should become comfortable thinking about using for loops for that purpose, right? So it's a repetitive action. In this case, I need to think about what my looping variable should be. And again, I try not to use things like I and K, but I try to use informative variable names. So here, this abbreviation for subject, I know that I'm going to have 50 participants. So I'm going to loop from start at 1 and go through 50. Okay. So when you're given code, which is what we have here, one nice thing to do when you're dealing with loops and you're trying to understand how they're structured is find the beginning and end of the loop. So MATLAB has a nice tool for this, where when you place your cursor by the beginning of in this case, our for loop, you see down here that it tells you the line where it ends, so line 144. Okay? So everything between lines 34 and 144 is within this for loop. And the way to think about this is that these are actions that we're performing for all participants. Okay? All right, so once I step inside my for loop, now I know that this variable exists, right? So it's available within the for loop. And the first time we go through, it has a value of 1. The second time we go through, a value of 2, and so on. So now I want to use the value of subject, or subj, to load my file name. And you'll remember that we did this in the example code where we use the simulated data, where we create a file name by by building what we call a character array. So this just has the prefix essentially of the file name. I then take my indexing variable, convert it to a string, so using num to string, and then I append or add .mat at the end. So again, one way you have functioning code, so one way that you can start to work through it once you're within a loop is I can take my indexing variable, copy this, I'm going to paste it in my command window, and I'm going to set it equal to a number. Okay, so in this case, 1. So what this will allow me to do is to now run the code that's inside the for loop to see what it does. Okay. So in this case, I'm going to just highlight this whole if statement, and logically I can walk through. So if subject is less than 10, I know subject is 1, so I should be in this part of my if statement. I'm going to have subject 0 and then num to string of the number 1. So this should be subject 01.mat. So I'll right click this, evaluate selection, and then see what the outcome was, right? So I want to go back to my command window, look in my workspace, and check file name. So file name is subject1.mat. Right. So that works. So now that I have my file name specified, now I can just load it. So I can just highlight this, evaluate, and you will see that this loads a structure S. And hopefully you'll remember, clear our console here, if I type S, that this is the structure that holds all the data for my participant. So we've already reviewed the contents of this data structure, but it's always good to do this multiple times to make sure you're comfortable with the data you're analyzing. Okay, so now what we're going to do is we're going to initialize some new variables, and these variables are going to hold the joint angle trajectories for each task. So it's a little bit confusing, but if we look closely at the data, what we'll find is that the participants did not all perform all the same task, and they even performed different numbers of trials for each task. And so I need to write code that's flexible enough to handle that variability in my data set. So what I'm going to do here is just create several empty arrays, and I'm going to fill them in as I move through my data set. So let's think about that a little bit more deeply. So if I take my first participant here, and I do s1.data, so actually I don't need that one, so that's just s.data. So here again, remember we have a 1/42 structure, that's the data field, and that corresponds to the 42 trials that this participant completed. So if I look at the first trial, I see that the task here is walking. Now if I look at the 23rd trial, this person is still walking. If I look at the 36, now they're doing toe walking. Okay? So as I cycle through each trial, I can use this field task to make sure that I know what the person was doing for that trial when I go to extract their respective joint angles. Okay. So again, we're going to initialize these as empty arrays. And next, what we'll do is explain how we set up the for loop to loop through each trial and extract the data that we need. So now what we want to do is, now that we've loaded the data for one participant, now we want to loop through all the trials for that participant. And so what we're going to do, I'll scroll through to talk through the code at a high level before getting into the details. So again, for each trial corresponds to a different task. So we need to know what task the person is performing. And then based on the task that they're performing in that trial, we're going to store the data or the joint angles in one of our variables that we just initialized. From there, we're then going to plot the data for that trial on the appropriate axes on our figure, and then we're going to do that for all of the trials. All right, so first, we want to, for this participant, we already know that there are 42 trials, but that's not going to be the case for everyone. So one of the things that you want to get into the habit of doing is to write things in terms of variables or parameters. So what do I mean by that? So I know that I want to loop through all my trials. We're going to start with trial 1, but I don't necessarily know how many trials I have for each participant. I could go in each file and create, on a spreadsheet, a list of the numbers of trials for each participant, but that will be really cumbersome, right? And there's the chances for errors when I do that. So instead, what I want to do is use the file itself. I want to extract the information from the file. So in this case, if I just go into the data field for my structure and use numL, which is again number of elements, this highlighted piece of code will tell me exactly how many trials I have for that particular participant. So that code will work for all participants no matter how many trials they have. Next, what I want to do is extract the information from that data set or that trial that corresponds to the task that the participant was performing. So again, as we just saw earlier, that information here is stored in the data field for that particular trial. And then again, I use dot indexing to extract the information that corresponds, or the text that corresponds to the task that they're performing. So now I have a variable task that is either walking, hill walking, toe walking, etc. So next, what I want to do is I want to make some decisions based on the task that the participant is performing. So I'm going to use a new construction that we haven't seen yet, at least here in MATLAB, which is the switch case construction. And what this is going to do is it allows us, it's basically a bunch of if-else statements. But in this case, I have defined conditions that are based on text-based, and this is just a little bit of a simpler code than a set of if-else statements. So what we're going to do is we're going to use our variable task, and we're going to switch and make different decisions based on the value of task. So this variable can have, there are different cases for that variable. Right. In one case, it could be walking. That the actual text that corresponds to this that this variable contains could be walking. And so there are a few things that I want to specify. So one, because I'm making the figure from the text, I want to specify in which column am I plotting those data. And so if we pull up this figure, remember that in MATLAB, when we want to create a set of subplots, which is what we have here, they're numbered starting from number 1 in the top left, 2, 3, 4, 5, 6. Okay. So the number from left to right, top to bottom. So I know that my first column corresponds to panels 1, 6, and 11. And these are where I want to plot the data for my walking trials. And so I see here that I've created a variable panels that has those numbers. So I don't use those immediately, but they're going to come back later when I create my figures. Next, I have a variable trial name that I'm creating, and that will be used later when I add titles to my figure. And then finally, I want to append the data for that trial in the corresponding variable. So this is a little bit of a tricky line of code. So remember, for each trial, I have 12 joint angles and 101 data points. So a 12 by 101 matrix. And I have multiple trials of the same task. And so what I want to do is store each of those matrices as a separate, essentially, page. So I want to put, once I have trial 1, if I have trial 2, I put that behind trial 1. Trial 3 goes behind trial 2, and so on. So this is what we call concatenation. And here I'm using a function called cat, which does concatenation. And the first entry says, along what dimension do you want to concatenate two arrays? And in this case, when I think about these separate pages, that's my third dimension. And so the next input to this function is the first array. So this is just whatever exists in this variable. So my first time through my loop, remember that this is an empty array. Okay? So there's nothing there. So what it's going to do is then take my joint angle data, so that's everything that's highlighted here, and it's just going to put that inside my empty array. Okay. The next time through the loop, if there's another walking trial, it will just add that matrix to the back of this one, and I'll have two dimensions, or two arrays back to back. And so, take some time, pause if you need to, make sure you understand these lines of code, technically these lines of code. And then once you have an understanding of how they're structured and their purpose, the same thing holds for the rest of these cases. Okay? So it looks like quite a bit of code, but it's repetitive. Right? So things that change, I just change these numbers. So instead of my first column, now I'm in my second column. Here I'm in my third column, and so on. And again, the column corresponds to the part of the figure where I would be plotting those data. So now let's imagine that we've gone through this sort of switch case loop here, or construction. Next, I need to actually plot my data. So again, as you'll remember, we'll use subplot here, which we've used before. And again, the inputs to subplot are the number of rows, the number of columns, and then the specific panel where you want to plot those data. And so this is now where my variable panels comes into play. And I have, 3 rows that I want to plot. So let's just put the figure side by side. Okay. So 3 rows, 5 columns. And then again, when I'm walking, we're going to do rows, panels 1, 6, and 11. Okay, and then we're just going to plot our data. So in this case, when we want to plot ankle, knee, and hip, remember I said we have 12 joint angles. So I need to make sure that I'm plotting the right data on the figure. So as you can see here, what we're doing for the ankle is that we're plotting the 10th row of the angle variable. Okay. So how do we know this? Let's see if we can find that information. So I'm going to scroll back to my text here. So here they're talking about the subject x.mat file, and let's see, where are we? Markers. Let's see. There it is. Okay. So here is the variable that we're looking for. So there's a field within my data called angVarName, which just tells us the name of all of our joint angles. So let's go to S. So here we have that field. So if I just type s.ang, remember I can press tab to autocomplete and press enter. And so here I can see the name of all the joint angles, right? And so I can count here. So there's 12, 11, 10 is going to be my ankle flexion. 9, 8, 7 will be knee flexion. 6, 5, 4 will be hip flexion. Okay. And so you can see we have 10, 7, and 4 corresponding to the ankle, knee, and hip. So take another pause if necessary, just to make sure that you're comfortable accessing and moving through data structures in MATLAB. So here our main structure has the name S. We then are interested in the data field. Again, that field was a 1/42 array. So here I use in parentheses trial num to indicate which element of that array I want to access. And then that array has many fields, one of which is A and G, or the joint angle data. And once we sort of dive down to the joint angle data level, that is now a variable that has 12 rows and 101 columns. So in this case, when I want to plot those data, I'm only interested in plotting the ankle angle. So I'm only going to extract the 10th row, and then the colon here indicates that I'll extract all the columns from that variable. So in this call to the plot function, I also have a second input here, which is B, and that just specifies that we're going to plot these data with a blue line. Lastly, I turn my hold on because I know I'm going to add more data to this figure. All right, the next 3 lines, again, whenever we make a plot, we want to make sure we annotate it, label it, and add units as needed. So here we have our X label, which is essentially the percent gate cycle, but this is the title that was used in the manuscript. We have our Y label and our title. Okay. So we do the same thing again. Once you understand these lines of code, pause if necessary. But once you understand these, then we just make subtle changes in the next two blocks to plot the same information for the knee and the hip. So we need to tell MATLAB now we need to move to a different panel. So we update the third entry to our subplot call. We update the row of our matrix that we're plotting, and then we update some information on the y-axis labels. All right. So what we're going to do here is I'm going to put a breakpoint, and we're going to just run the code to that point. Press run. I'm going to change my folder so that it moves us back to the home folder. And now we can see what happens the first time through this code. So these are all the data, or all the joint angle trajectories for our first participant. So you'll note that there are only 4 columns here. And that's because this participant did not, we don't have data for the step descent for this participant. You can also pretty clearly see that they do more walking trials than any other trial, and fewer stepping trials probably than any other trial. Right, so as expected with real data, even though the task is repetitive, the traces aren't exactly the same. There's some variability from trial to trial. So in some cases, we might want to take a closer look at these data, make sure that there are no outliers that are sort of clear red flags that there may be problems with our data set. These look reasonable, and so we're going to continue from there. So now what we want to do is, for this participant, we want to take each of these these bouts or types of walking, and we want to compute the average joint angle trajectory. Okay. So for instance, we're going to take these, let's call this 30 trials, and we want to average them all together to get what this person's average ankle angle looks like during walking. So one of the things that we did here, so this is a bit of a cumbersome set of code, and it's annotated here, but because there are some cases, for instance, like step descent, that this person didn't do, before we try to compute any averages, we have to make sure that the data exists. So one way that we do this is we use an if statement. So I say, okay, well, if the variable joint angles walking exists, then let's compute the average. So to test if this variable really exists or is not empty, we negate the isEmpty function. Right, so if this was empty, isEmpty would return a 1, and then not isEmpty would return 0. If there are data here, isEmpty would return a 0, not isEmpty would return a 1. And so if there are data, then we move to this next line. We compute the average of all the joint angles for that participant. And here, when we use the command mean, we have a second argument, that's number 3, and that's going to average across all those pages that we discussed, right? So each trial, we have a matrix of data, 12 rows by 101 columns. We have many trials. Again, let's ballpark, we have 30 for walking. So we want to average across all those trials to get one matrix that's 12 rows by 101 columns. And what we're going to do is we're going to store that matrix in another variable that I call average joint angles walking. Okay. So ultimately, this is going to have 12 rows and 101 columns and 50 pages, where each page corresponds to the average joint angle trajectories for one participant. Okay. So if for a given participant, they did not do a task, right? So if this line is false, then what we do is we just store a set of nan values for that participant. Okay. So again, just like the earlier parts of code, make sure that you understand this block of code. And if so, then the rest of them are pretty much the same with just some minor changes to accommodate different trial types. All right, so I'm gonna continue to here. Actually turn this breakpoint off, continue here. So now it's going to take a while. So now it's going through all 50 participants. So it takes a little bit of time here. And then once that's finished, we can take a look at our figure and then finish up this bit of code. All right, so there we go. So now you can see that the figure on the right updated and has a lot more data. In general, you can see that the trajectories look fairly similar, and this is now all bouts of walking for all 50 participants. So the last thing we're going to do here is we're going to move back to our home folder. So I just use the step command to move one line of code. And then what we have here is we want to save our results. So we've computed several different variables, and we want to be selective about which variables we save. Right? I don't need home. I don't need to save home. I don't need to save the value of trial num and task and so on. But I do want to save all the average joint angle trajectories, and I'm going to save them in a file called average joint angles. Okay. So with this use of the command save, you save followed by the file name, and then after that is a list, space separated list of variables in your workspace that you'd like to save. Okay. So I can just continue there. I finish up this code, and now I should have a file called averagejointangles.mat in my workspace. So if I go here, here's that file. Okay. So let's see, if I clear my workspace, drag this in, now I see I have my average joint angles. All right, so the next thing, what we'll do in the next video is we'll take these average joint angles and actually run them through a statistical analysis and create a publication quality figure. Now what you'll find, again, in the README file for GitHub, as well as in the folder, the GitHub folder for MATLAB, is a set of incomplete scripts for the analysis that we just walked through. And for each script, there will be instructions as to what you need to complete. And so you should take some time to try to complete those exercises to make sure you understand the various things that we were doing as we set up this first part of our data analysis pipeline. If for some reason it takes you too long to solve one of the steps and you are not unable to get help, you can always just move to the next file, and it will have a completed version of what you needed to do for the previous exercise. All right, so I'll see you all in the next video where we finish up our analysis.